Well, hi there. So this video, we're going to cover costs. The first four costs that we're going to learn about are all in the short run. Marginal cost, average total cost, average variable cost, and average fixed cost. It's a costs bonanza. So let's get started. Okay, so the top half of this page is a little table that outlines everything you really need to know about these four different types of per unit costs. So up to this point, we've been talking about kind of measures of like total costs, but all of these are per unit. And that means that like marginal cost would tell us this is the per unit change in cost, or the average fixed cost of a unit in particular. These are not total amounts, these are per unit. That's an important thing to kind of keep in mind as we're doing all of these. Now, the first one that we've actually talked about before is marginal cost. And so it's just the change in total cost associated with a change in total product or output. And what I'm going to write here is a formula that kind of rewrites that. So total cost divided by the change in total product. And that way I kind of have a little formula cheat sheet in a way right here. Now, mostly the reason we care about marginal cost is it tells us how we maximize profit, right? That most important rule in all of microeconomics. Now, the shape of this curve is going to be kind of J-shaped or Nike shaped, right? So some people call it like a Nike swoosh. Some people say it's like shaped like a J, but it's got this little tail hook at the beginning where it comes down and then goes back up. And the reason why it's shaped that way is it comes down, as we talked about before, because the workers are specializing and we're getting more and more marginal product out of each worker, right? So that's allowing for us to get more product per input, which is actually going to cause the marginal cost to fall. Now it's going to start going back up again because of diminishing marginal returns. In the short run, we know that we have some of our inputs are fixed. And as a consequence, when we keep adding more variable inputs, what's going to happen is that we're going to get less and less marginal product out of those variable inputs. And as a consequence, the cost of our outputs is going to start to rise on a per unit basis. So it's going to come back up again because of diminishing marginal returns to labor with fixed capital inputs. Or you could have just said diminishing marginal returns to the variable input with any of your fixed inputs, right? With any one input fixed, you're going to see this phenomena occur. Now, the other three types of costs are all average costs. And so these are actually going to be a total amount of a cost, and it's in the name, right? Variable, fixed, and total, divided by the quantity of output. So the first one that I actually want to talk about is ATC. This is maybe the second most important of these four types of costs. So the most important one is obviously marginal cost, tells us how we maximize profit. The second one, average total cost, is the total amount that we have in costs divided by our total product. So it's literally just TC over TP. And take a moment to distinguish these two, right? This one is a derivative function. This one's not. This is saying just what's the total amount divided by the total amount. And what's cool about ATC is that if ATC is less than the price, I know the firm's earning a profit. So if the average cost of a unit is $5 and your company is selling the product for $6, I know that you're earning $1 of profit per unit, actually. Now, if I know the ATC is greater than the price, I know your company's losing money. And in fact, that's the loss per unit. So it tells you how much profit or loss if you're operating, right? So if your company's producing units, I can know either you're in loss or you're in profit, and I can actually see how much profit or loss per unit it is. Now, the marginal cost has to cross through the average total cost at the average total cost's minimum point. This is a really important graphical thing to understand. So if I say that we've got this marginal cost curve that does one of these, right? That's marginal cost. The ATC is actually going to be kind of U-shaped. It's going to look like that. And this minimum point of the ATC has to occur right where marginal cost crosses through it. So ATC is going to look like that. This relationship must be true. So like, for example, if you were to draw a graph on a test and you went like this, right? That's wrong, right? This is mathematically impossible to do, right? So you cannot do this, right? Never. It's only like this. It only will ever work this way. And in fact, you would get the problem wrong if you drew it that way. And the reason why is that these marginals are actually kind of like we've talked about before. It's like an additional cost. It's going to affect the average. And so in this first part where the marginals are below the average, so like we have kind of quantity axis right here, as we kind of have these first few units where the marginals are below the averages, it's going to cause the average to pull down. It would be like getting an additional grade that's lower than your GPA. What's it going to do? It's going to lower your GPA. It's going to lower the average. But once that marginal cost crosses through, and we know it's going to start rising, it's actually going to cross through the average. And once it starts to exceed the average, it's going to cause the average to start to bend back up again, because it would be like achieving an additional grade that's higher than your GPA, higher than your grade point average. And that's going to cause the average to bend back up. Now, the reason that it's U-shaped, right, is similar to why marginal cost is what it is. Initially, the fixed cost of your product is a big chunk of your total cost. And so as you're producing more and more units, you're actually able to kind of spread out that fixed cost over more units. And it's basically causing the average to get spread lower and lower and lower. A second reason is that the variable cost, which is what's driving your marginals here, is also actually falling, right? So there's kind of two reasons why this ATC is decreasing in the first range. And one of them is the marginal cost is less than the average, and the other is that we're spreading out the fixed cost over more units of output. Now, at a certain point, the marginal cost is going to cross through that minimum point, and that diminishing marginal returns is going to actually cause the average to bend back up. So this pulling of the average back up is actually happening for the same reason that we would say marginal cost is inexorably rising. Okay, now let's take a look at average fixed cost. This one's actually the least important of them, right? So you can say like most, and then second, we'll put there. And this is the least important one of them all. This one is only helpful to know if your firm is shut down, how much money would you lose? Because when you're shut down, like your company's not currently producing any units of output, this is telling us essentially how much you would lose. And you can use this number to figure that out. How much you would lose is equal to your fixed cost, right? And this is because the fixed cost is your loss in that scenario. Now, just to give us like a quick little, total fixed cost divided by your total product. So that's our formula. All this one is saying is like, how much is your fixed cost, which is always fixed in the short run, right? So we'll say short run per unit. That's what all of these are. In the short run, that fixed cost is fixed. Otherwise, we wouldn't call it that. And we're dividing it by more and more units of output. And so this one is going to actually be L-shaped, right? It's going to be L-shaped. It'll come down, and it'll actually become an asymptote to that quantity axis. Woo! It'll look like that, AFC. The way that we would use it is like if your company was shut down, I could say, let's pick this quantity and this average fixed cost. And if my average fixed cost was 3 at 10 units, that means that like any of these, even though I know I'm not producing, I could multiply these together and find that the area would be my fixed cost. And that's how much actually I would be losing, right? And so we kind of can observe that this was really just helpful to say, if the firm is shut down, I can use this to actually figure out any quantity times that average fixed cost is going to equal to the fixed cost, which is our shutdown loss in that scenario. Now, this one here, and I'm going to return to this little note in just a second. This one here, average variable cost, is probably our third most important. This one's useful for when we determine whether the firm should be operating temporarily while they're losing money. And I know that initially you might be like, well, why would they operate when they're losing money? That's because if they shut down, they're still going to lose money. They're still going to lose their fixed cost, right? That's what we just kind of established up here. So let's say your company is a restaurant and it's 3:00 in the afternoon. You're not going to have a whole lot of customers coming in. But if you close the doors, you're not going to have any customers, and you know you're going to lose your fixed cost, right? However much money it takes to operate or to just have that oven and have the building and the rent and that kind of stuff for those few hours. So during that 3:00 restaurant hour, what restaurants will look at is, does the amount of customers coming in, is that enough to cover all of our fixed cost and maybe a little bit of our variable cost? And if that's the case, then they should operate, because they're better off doing that than losing their fixed cost. Right? Now, this is a little bit easier to understand with a graph, and we're going to come back to it later in another lesson. But in short, this one is, and we'll just write the formula, variable cost divided by total product. This one is used to know whether we should be operating in a loss. And this is called the shutdown rule, actually. And again, we'll come back, shutdown rule. We'll come back and look at like the application of that rule later. But for right now, I'm just telling you like why we have this. If the average variable cost is less than your price, you should operate. But if your average variable cost is greater than your price, then you should shut down. In other words, if your price gets really, really low for your product because you have very few customers coming in, right? Your product is so little demand for it that the price is really, really low for it. and it's below what your average variable cost is, then you should just close your doors. But if your price is above your average variable cost, you should be operating, at least in the short run, even if you're losing money. Now, this one, average variable, is also going to be always less than the average total, because the average total is actually the sum of the average variable and the average fixed. So if we add the fixed and the variable cost together, we get the total cost, right? That's what this is saying. Fixed plus variable equals total, which means that the average variable plus the average fixed, these two added together will give us the average total. Now, this part, average below the average total cost, it's going to get closer actually as the output rises. So what we actually see happen, draw a little sketch off to the side, is we'll have a marginal cost that we start with. And then we have an average total that looks like this, average total that looks like that. And then you're going to have an average variable that's below it, hits its minimum, right? AVC's minimum is also going to be hit through with that MC. And then it's going to come back up and get closer and closer and closer to the average total cost. Now, if you don't perfectly draw it where it's getting closer and closer, that's okay. But it actually is mathematically true that that would be the case. Now, average variable is going to be that same U shape as our average total. It's just the average total is bigger than the average variable because it includes it, right? Average total includes the average variable. And the reasons why the average variable behaves the way it does is actually the exact same as the reasons for the marginal cost curve. We wouldn't say that this fixed cost thing, the spreading effect thing, is happening with average variable cost. And the reason why is that average variable cost doesn't include the fixed cost. So this initial decrease in average variable cost is only happening because these first few units, our marginal costs are below that value. But as marginal cost starts to rise again, as this number gets larger, it's going to cause this AVC to flatten. And then once marginal cost is above the average variable, it's going to cause that average variable to bend back upwards again. And again, that's just because of the diminishing marginal returns that's occurring with the marginal cost curve. Now let's take a look at a little data table to see the underlying relationships among these different measures of cost. So this data table is almost like a Sudoku puzzle, and we'll see how far we can get with kind of checking things out. Now, we know that at zero total product, one thing to know, well, we don't have any variable cost because we're not producing any units. So that also means that we know that our fixed cost must be equal to 12, right? We know that that must be true because at zero output, total cost is equal to fixed cost. So then I can work backwards and fill in this column and say, well, this must be 16 because 4 plus 12 is 16. Now I can figure out what's my marginal cost of my first unit. Well, there's two ways I could do marginal cost. It's the change in variable cost associated with a change in output, or it's the change in total cost with 1 unit of output. And so that's just going to be 4. And again, the only reason why we would say we could use that variable cost column is because the fixed cost is never going to change. So marginal cost is really only dependent on the changes in the variable cost. Now we can work kind of backwards a little bit more here. I'm going to come back to the averages at the end. Let's take a look. 3 is our marginal cost here of the second unit. And so that means that that second unit cost me $3 to make. So this value has to be 19. And that means this value has to be 7. And again, the difference between these two must be 12 because that's what our fixed cost is. Now I've got 21. I know my fixed cost is 12, so I'm just going to subtract 21 minus 12, and that's going to give me, I just had a total brain fart, 9. Whew, I don't know why that happened to me, because 21 is our total minus the fixed of 12 gives me 9. So now how much is my marginal cost? Well, 7 to 9 is 2. You could also have done 19 to 21. That's also 2. And here we're still in the range where marginal cost is falling, right? So marginal cost is falling because our workers are specializing. Now let's see for the next one, 9 to 12, that's 3. So now it's starting to come back up again. And I know that if this marginal cost value is 3, then I know that this one has to be 24. Again, 9 to 12 would be 21 to 24. And now I'm stuck. Oh my goodness. What do we got over here? We have AVC at $3.60. So the average variable cost of that fifth unit is $3.60, which means that if I multiplied $3.60 times 5, that'll just clear out the average and give me the variable cost. So 5 times $3 is 15, and 5 times 60 cents is $3. And so the total variable cost of 5 units must be 18. And let's double check our math here really quick here. $3.60, right? $3.60 times 5 is equal to $18. So that tells me then that my marginal cost was 6, 12 to 18, and my total cost of these units was 30. Now I know my marginal cost is 9 here, so I can work backwards to 27. And then 9 to 30 is to 39. Okay, so we have 30 goes to 39 because of that $9 to 18 to 27. And again, I'm going to come back and fill out these averages at the end. 39 to 49 is 10, so this is 10 here. And so that one makes 37. And then here, oh, they filled this one out nicely for me. There's a couple of ways I could do it. 12 goes to 49, so that's 61. I could have also done what is 49 plus 12. 49 plus 12 is 61, right? Because that's the variable cost plus the fixed cost. Now I've got 61 going to 75, so I know the marginal cost of that ninth unit must be 14. And I can then take 49 and 14 and add them together, and I get 63. I hope that's right, 63. I'm doing all of these in my head, so I know somebody's going to catch one if I've gotten them wrong. 49 plus 14, yeah, that's 59 plus 3, that's 63. And now I've got my very last one is another one of these average ones, but this one's not too bad. It gives me average total is $9.10. So the 10 units, well, you can just say, well, if I want to clear out that average and just figure out what's my total cost, well, $9.10 per unit times 10 is $91, right? So it's just moving that decimal place one over. And I can do the same thing here with this one. $7.90 times 10 gives me $79 for my variable cost. And again, the difference between total and variable should be 12, and I'm checking that that's true. 91 minus 79 is our fixed cost of 12. And I can see 75 to 91, that's $16, and 63 to 79 is $16 for my marginal cost values here. Now the averages are just taking what these total numbers are and dividing them by the total product. And so the first couple hopefully are going to be relatively easy. 16 divided by 1 is 16. Right? And then I did this one for you. 19 divided by 2 is 950. 21 over 3 is 7. 24 over 4 is 6. 30 over 5 is 6. And so our average actually kind of bottomed out at a couple of numbers there. 39 over 6, I'm just going to do this one because I'm 39 divided by 6 is $6.50. And so now my ATC is coming back up again. And then I've got 49 over 7 is 7. Right? So these are all in dollars. And I'm going to kind of notice something here. Marginal cost crosses through that average cost values right actually at that $6 value. So I could even construct a little graph if I wanted to and show where this would be. We've got coming down and then coming back up, marginal cost. And where that happens, boop, right there, that ATC value, and that actually should be flat, is what's that quantity? 5. So that's actually happening at 5, and this is $6, right? So that's actually what's corresponding to this fifth unit right there. Now let's take a look at the AVCs. Well, the average variable is just what's your variable cost divided by your total product. So 4 over 1 is 4. This one's done for you. 7 over 2 is 350. 9 over 3 is 3. 12 over 4 is 3. So here, that one's bottoming out again as well. 18 over 5 is done for you. It's $3.60. And then we've got 27 over 6. 27 over 6, well, it's 27 divided by 3 is 9, and then divided by 2 again is 450. And then we're going to fill out our very last one. 63 over 9 is 7. And so here, let's test this out again and see, does average variable cost, where is this point occurring? Average variable. And I know average variable has to be less than average total because the average total includes it. So let's see. Marginal cost, boom, right here equals the average variable cost at what level? 3 and 3, and that's occurring at quantity 4. So at Q4, and then that's $3 right there. So you can kind of graphically actually see where some of these relationships are with these. One last thing to point out to you, right? Let's take a look for this very first unit. Average total cost was 16, average variable cost was 4. The average fixed cost, 16 minus 4 is 12. Now let's actually work backwards and see. Well, if I take that average and I multiply it by the number of units, I'm going to get fixed cost, which is 12. Let's do this again. 650 minus 350 is 6. The average fixed cost of the second unit is 6. 6 times 2 is 12. I'll do it one last time to prove the concept. 7 minus 3 is 4. That's the average fixed cost. 4 times 3 is 12. And so you can actually use these average fixed costs to kind of help you solve some of these types of problems. I think this is such a cool little topic because of all of the relationships. I hope you do too. I'll see you next time.